So we were running low on time last time, so let's see if I can get it all finished in this tutorial. All right, now back here we've got the formula for sigma squared. Now remember, this is for variance. This isn't quite what we want, but that's okay. It'll help. So let me make this a little smaller so we can see what we're doing here. Okay, lower bound. Come on. Sorry, I got to fuss with my spreadsheet here so you can see. There it is, lower bound. And I didn't say this before, but it's for sigma squared. Okay, this is for the population variance. So you're making an interval. It's equal to n minus 1, that's your degrees of freedom, times s squared, which is the 100, divided by alpha over 2. That's this critical value, the chi-square for alpha over 2. There's your lower bound. Upper bound for sigma squared. That would be equal to the same thing, n minus 1 times s squared divided by, this time it's the other critical value, the 1 minus alpha. There we go. Now that is not what was asked for. That's for sigma squared. We still need the lower bounds for sigma and the upper bound for sigma alone, because that's what they asked us for in the problem. Let me show you. Right here. They say construct a 95% confidence interval for the population standard deviation. All right, back in chapter 3, we learned that standard deviation, sigma, is the square root, so SQRT, of sigma squared. Or you learn it in algebra class. Square root of a square gets you just plain sigma. There, that's what they're actually looking for. That's the confidence interval for the standard deviation. Now, are there other ways to do it? Of course there are. Let's first see StatCrunch, because I happen to have StatCrunch open. Here's my data. Isn't it beautiful? You go to Stat, you go to Variance, one sample. This time you're doing it with data because you have data in the column. So click with data. That's the data I'm interested in, age at the first crawl. Click Next. We want a confidence interval. We want 0.95. Click Calculate. Let me copy for a second. I'm going to go here and maximize this window so you can see. Okay, now I know what you're thinking. You're thinking, whoa, those answers right here, those don't look right. They're these ones. They're for sigma squared, because remember, when we were in StatCrunch, what did we select? We selected variance. See it right there? All right, so if you use StatCrunch, then you have to then take the square root of both of these numbers to find these two numbers, which are your answers, 7.08 and 16.9. Okay, so it even shows you, look right there, it's telling you it's doing sigma squared, right? So believe it, this is for variance. The other option, go click on the column of data, go to add-ins, go to DDXL, choose confidence intervals, and you want to go down here to chi-square confidence intervals for SD, standard deviation. Click that as your data set and say OK. And then you got to tell it what you want. You want a 95%, so click 95. And there are the answers. Look at that, 7.085, 16.981. So copy window. You can do text or picture, whichever way you like. I'll do picture this time just for fun. See how it works. See if it works okay. There it is. Cool. And just to show you the difference, in case you're interested, if I copy as text, then when I go to paste, it fills into the different cells. So whatever makes you happy. In this case, I would imagine text might be a little more useful, but it's up to you. So this one actually does standard deviation. StatCrunch does variance. So if you're asked for an interval for variance, StatCrunch might be better. If you're asked for an interval for standard deviation, DDXL is great, but DDXL only works if you have a column of data. So I guess all in all, you're better off just doing all of this from the start, and then you won't have any problems now, will you? All right, so we are done with 9.4. I will hope to see you here next time.